Now.
I don't know, it'll take 8 hours.
I hope not. Oh my gosh.
Okay, so we're starting with chapter 4. It's super easy.
Yes, I'm just pulling it up here.
So we just have to do part 2. And then do the quiz.
Alright, so let's see. We need to find all 4 possible outcomes for each roll. Calculate the mean of this discrete random variable.
Oh, I see. So, back in the book, what was the formula? Where's the book?
Coming. Oh. That's
Onward, ever on. Oh, we're still
wrong chapter. Go back.
Wait for it.
Okay.
So, keep going. It's right there. Ah, I'm right here.
This one? Oh, right. So, on this one, all we
Yeah.
have to do is we have...
There's only 4, so
we have to just find the mean of 4. So to find the mean, especially with the dice, you
Yeah.
have one side. So you got one side versus all 4 sides.
Yeah.
Oh.
So if you bring up the table that they have there, they have the value, which is each side,
Mm-hmm.
and then the count, which is 1 over the total,
Yeah.
or the 1 over the highest
So it's-
number.
yeah, basically it would be 1/4 in our case.
Yeah. And then you multiply that by the value. And
Yeah.
that'll give us the...
Did I do that right? Is that how we did it?
I feel like we were down here.
Well, we did that one later. This one we did...
Mm-mm.
No, because that's the next problem, isn't it?
I don't know. Nope, that's the one we did.
Because the probability of getting each one is...
Are we finding the sample mean or the population mean?
the
What do you...
mean.
What?
Well, I checked
We're
the... You got it right.
Okay, so the
It's the same thing. It'll be the
We're
same.
probably... just the standard.
Okay, so let's just do 1 times 0.25, which is 0.25.
Yeah.
And 2 times 0.25, which is 0.5. And 3 times 0.25, which is 0.75. And 4 times 0.25, which is 1, and add them up, which is 2.5.
You do the math.
Yeah. So the answer, so the mean is 2.5.
Let me just get this all typed up here.
No, really. I'm sorry.
Hey, I'm gonna get healthy.
At a cost.
Find out the pollen video.
No one watches these things.
Except my...
I hope that they just go to see who's on it, like whose picture they can see on it, and how long the time was for.
Yeah.
And so, should we make 2 separate ones for each group meeting?
I don't think we have to. I think we just post the same one on each one and say that it's... Well, we could. I mean, we could just stop it and restart it. So everyone-
Yeah.
Okay.
Okay, so next, calculate the standard deviation of this discrete random variable. Okay, go down. Standard
this
deviation?
No.
No.
It was this one.
This one. Okay. So, we're going to do...
Do you want me to explain this one?
No. I
Okay.
got this one.
You do this one.
So, we're going to go with 1 minus 2.5 times 0.25.
Wait, that's 1 minus 2.25 squared.
Squared. Sorry. 1 minus 2.5 squared times 0.25.
So do you understand the equation in the book?
I did when I was reading it last night. Let me review it. I've had some hold on. Bring it up here.
Cute.
Okay, so we're just doing. So it's 1 minus 0.25 squared times
2.5.
0.25. Wait,
So
what?
1 minus 2.5 squared. So that's the mean.
Yes, 1 minus 2.5 squared times
0.25.
0.25.
Yeah.
And then 2 minus, yeah.
Yeah. And then you add them up, right?
Yes, then you add them all up to
Square
get
root.
the variance.
Square. Right?
And then we square root the variance.
Square root the sum of
Yeah.
the variance.
Yeah, to get the standard deviation.
Yeah.
Yes. Okay.
So we get
So on the answer key, it had, where'd you go? Like we just filled it out. We just rounded it up. I don't know how many.
I guess it doesn't really matter.
Yeah.
I'm just gonna put that just in case. Even though we don't have to write it. Alright, well that was easy. What did you get?
I'm still. I don't have a physical calculator, so I'm trying to use the one on my computer.
Oh.
Oh, that sucks.
Yeah. I need to. Well, I had a TI-89 like a long time ago, but I don't know where it's at. Is that what it's called, TI-89?
Mm-hmm.
Yeah.
I think it was an 84, 3.
I guess I should just go to Walmart and get myself a or Target or something.
There's one, I can't remember what kind it is. It's just a scientific calculator. It's pretty cheap. I think it was $12, but it's really nice.
Yeah.
Yeah, that's disgusting. Okay, that looks like that. Every time.
You didn't worry about it. Should probably drink this before it gets too warm and disgusting.
Mm-hmm.
Hmm?
As long as I don't have to taste it, it's fine.
How do you not taste it? That was cool.
Yep, that happened.
Okay, this is not working. I can do the square root, but I can't do squared. So.
1?
Well, I understand it. So what did you?
Oh, yeah.
1.118.
1.118 is the standard variance.
Yeah.
Yep. Alright, now let's go take the quiz.
Okay.
Alright, that was easy. Let's take the quiz.
Yeah.
Not you. You're quitting?
That one will work.
Oh, right.
Six. Come on, 6. Repeat strong. Appointment.
What was 27, was it?
The
Oh, median,
median.
right. That was.
Oh, there's no paper for this one.
No paper?
Well, you know how before it had like a worksheet to do? Oh no, never mind. That's under the homework. Huh? I'm confused. I need more sleep at night.
Yeah, you could say that again.
Okay, so I have the quiz up.
Okay.
So, number 3.
Do not give probability answers as percentage. Human blood could be classified into one of our. The blood type and the proportions given in the table above are defined as probability distribution.
True?
I
True.
think so.
Because they all add up to 1, right?
Yeah.
Okay.
They do? Hold on. 85,
Yeah.
89. Yeah, 1. True. What is the probability that a randomly selected person in the United States has type O blood?
Okay. Is probability and portion the same? Because that's proportion. Probability.
Well, yeah, because it says rounded
Oh
to
yeah, because
decimal.
proportion. Proportion's right here. Okay. Wait. This is count, and that's the P of X, and then that says value times proportion.
Well, if you look at 2.2,
So it would be the probability, right? The proportion is a probability.
Yeah, I think so. So it'd be 0.45, right?
wouldn't it be the... Hold on. Where do you see proportion?
If you go down to where it talks about like all the charts.
Uh-huh.
So it says like column 1 is value, count is or column 2 is count, column 3 is value times proportion, and then they use the number for count. And then if you go down, the count equals P of X, and that's probability.
Sorry, I'm not seeing that chart.
It's in 3.1.
Okay. Right. Oh, value count, value times proportion. So wouldn't it be 2 times point?
No, because that's the sum. That's finding the sum.
Oh, we're looking for the
I
sum.
think proportion is, it just says X times P of X.
Okay, so just 0.45 then.
Yeah.
What is the probability that a randomly selected person...
Doesn't like head fish. Okay. So number 5 would be just 0.55.
Because it's 1 minus p of x, right? According to rule number 3 of the probability.
Mm.
Can you please read this out loud?
Yes.
Yeah. You're good.
So it was 1 minus the sum of those 3 numbers?
So it's 1 minus the
1
probability
minus
of O.
0.45. So, because everyone
Okay. No,
doesn't have...
1 minus 0.45 because 0.45 is what we're taking out of the equation.
Right.
We're looking for people who aren't type O.
Right.
Got it. Okay.
This question, man.
So, we were reading the next question.
Yeah.
Kind of interesting.
All right, let's see here.
You should read it out loud.
Do you want me to?
Yeah.
Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. That's good. The dogs are trained to lie down next to a specimen derived from a bladder cancer patient. Hangel, one of the dogs, demonstrated the identification of a specimen. Several bowls containing urine were lined up in random order. 6 of the samples were from patients who did not have bladder cancer. One sample came from a person identified as having bladder cancer. That's gotta be a fun study.
Oh, yeah.
Interesting.
Bowls of urine. Just
Yummy.
yeah. Hopefully the dogs don't knock it over.
Ooh. Okay.
Okay, if the dog guesses at random, what is the probability that they will correctly identify the dish containing the specimen?
Oh.
So there's 6.
That one's wrong. Oh, sorry.
Okay. There are 6 samples.
There's 7 samples.
Ooh.
Oh, 7 samples. That's right. Tricky, tricky. 6 of patients who don't and 1 that do, so 7 samples.
Alright, we have to do this one. So, X over the equals. $7.71. Oh my gosh, missed it. So, no, that's not right. No, yes it is. 7.71, because the last time we got 9.
9.
7 points. Does that make any sense? Oh, 7.7.
Aren't we just seeing what's the probability of, just like it's like saying what's the probability of rolling a 6?
Right, so it would just be 1 divided by 7?
7, yeah. So I have 0.142.
I think it's going to be 3.
Because you're rounding up.
Yes, 1 point, okay,
Okay, what's the next?
because of the 8. Okay, 0.143. Okay. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. Good job. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that the dogs can detect bladder cancer. There's little evidence. Well, if it's very unlikely that they would do it by random
I
chance.
know. I think this is a trick question. Because it says, yeah, in the question it says it's not likely that they would do this.
22 divided by 54. Alright, so the probability that if he just guesses is 0.143,
Mm-hmm.
and the probability that they actually had was 22 out of 54
Yeah.
is 0.407. I don't know why I couldn't make this.
Strong evidence then, huh?
It's stronger evidence,
Yeah.
but in statistics, the closer the probability is to 1 or -1, the stronger it is. The closer to 0 it is, the weaker it is. So technically it's strong evidence, but we haven't learned that yet. So
Let's just put strong.
alright.
That's what I would put.
Because it'd be like, if he guessed, it would be 7.72 out of 54, and this is 22 out of 54.
Yeah.
So it's strong.
Yeah, let's
okay.
do strong. Alright, M&M's are small chocolate candies. Given! Previously indicated that in the United States, this... Okay. So, to find green, we would add them all up, and 1 minus that number.
Yes. Why do I keep doing that? Oh, let's see here.
7 more.
Go to your daddy and tell him.
Papa, I'm pooping.
There you go.
I got 0.16. Did I do that wrong?
Yeah.
Thank you. So 0.2 plus 0.24 plus
What are you adding?
the numbers?
These numbers?
Yes.
Oh, okay.
Sorry, I don't know.
I did
Backwards.
0.16.
What are you doing? Stop rounding.
I got 0.16.
That's what I got.
Okay.
Did I add one?
0.13 equals 184. 1
Plus
minus
point.
10. 0.16.
0.16. No, that's red. That's red. Don't change that. Red.
Red.
I'm
Oh,
gonna change this one.
right.
0.16.
How in the world did you get 2 points?
I don't know! And this would be 0.84. I don't know how I did that. I'm sorry. Sorry.
Mhm.
Okay.
Okay. What is the probability that a randomly selected candy is green?
So you got 8 as 0.13, right?
No.
Because it's red.
What?
So number 8, you're picking out a red colored candy, so it would be 0.13, right?
Oh. Why did I... Okay.
I probably said green because I skipped 9.
Okay. Yes, it's 0.13. Thank you
Yep.
for bringing that up, because I totally put 0.16.
Don't worry, you can put that for the next one.
Cool.
Woo! Okay. Not green.
Not green. 1 minus 0.16.
0.84.
0.84.
Alright, next. Do we have these ones right?
Okay, basically,
So these ones look like review questions.
yeah.
So,
Well, just that one says review. Oh no, that one says review too. Still good to go over it. I was
okay. So,
Alright, so half of the observations are less than or equal to what number?
the median.
I mean the median, right?
half of the observations are less than or equal to
What does it mean?
the mean.
No, that's just the average.
Yeah, I think
So-
it's the median.
'Cause that's the midpoint of the numbers.
Because half of them have
Wouldn't it be the standard deviation? No, never mind. That's different. It would be less than or equal to the
It'd be the median.
median.
half of them have to be below and half of them have to be above because it's the middle.
Yeah.
Unless it's not equal.
That wouldn't make any sense. It would
No,
be
no,
the
no.
median.
It's the median. Median. 24.
Okay, what's going on here?
Based on the information on the table above, the top 25.
What, you went? Yeah. Good job.
Oh my God.
Now, do
Okay.
Based on the information.
Well,
25. Huh?
are we good? What?
For 12?
For 12? Yeah, what do you think 12 is?
Let's see, the top 25% of students scored above what number? Whoa, 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 computer. Go back. Go back. $27?
Yeah. I think so.
You really think so, or are you just saying that to be nice?
No, I really do think
No, we
so.
really do think so.
I'm just kidding.
Because it'll be in the third quartile.
Yeah. Which of the following statements is not one of the three rules of probability? Probability that an outcome will not occur is 1 minus the probability that it will occur. Probability is a number between 0 and 1. The probability is higher than the is high than the probability is positive. It'd be C.
Definitely. Okay, everybody submit it.
All right. Ready for this?
Submit.
Submit. Okay.
Woo! We did it! Woo!
Oh, yes! Oh, yes!
Good.
Way better than we did last time.
This one is yummy.
Oh, good job. Did you get those?
Yeah,
Good job.
get those.
Yeah.
Yeah.
Okay, can you close my door?
Okay.
Thank you. Good job. You did a really good job. Okay. All right. Onward.
Okay, do you want to do anything else with lesson 4? Or we should just end this one and start a new one?
I think we're good. Yeah, we can
But you haven't turned it.
stop.
That's true.
Stop and go.
Okay.
All right,
So.
stopping this one, gonna go post it, and then actually I'll just start the new one and post it while we're doing this.
All right.
Go. Stop broadcast.